Hey guys, today we are going to do Unit 2, Lesson 3B. Okay, this is a follow-up from Lesson 3. I felt like we needed to get some more practice in and to learn how to organize our work a little better. So that's what I have for us today, okay? I feel like the right triangles with the 45, 45, 90 are okay for us. We just need to know that so with the 45, 45, 90, I need to know that the 45-degree angles and the sides opposite them are equal in length, okay? And so based on what they give us, here's our objective. The information that they give us, we need to use this ratio, 1:2, but each side is being multiplied by x. My ultimate goal is to determine what is the x value. And that way I can plug it in to any of the other sides and figure out what my missing side or sides may be. So we're going to start by finding x. Once we know x, then we can figure out the missing sides. So let's look at example number 1 here. The hypotenuse is here. So what I have are my legs, okay, opposite the 45-degree angles. So what that means is that I know that the leg is 7, and so that equals x. So I already know x equals 7, so let's plug in the hypotenuse is going to equal, and I'm going to replace that x with a 7, square roots of 2, and I'm finished. Okay, so I had to identify the x and then plug it into this ratio. Let's do the same thing when I do not know the leg, okay? In this case, they gave me the hypotenuse is 4. So where the word hypotenuse is, I'm going to put a 4 because that's what the hypotenuse measure is. And then I need to bring down the rest of this to see the ratio. The hypotenuse equals x square roots of 2 in a 45, 45, 90 triangle. And so let me zoom in a little more. So what I need to do here for this equation, because the x is not by itself, I don't know the value of x yet. So I need to solve this value for x. So divide both sides by the square root of 2. All right. These cancel, leaving me with x on the right. Remember, yesterday's lesson talked about how and why we cannot leave a square root on the bottom. So multiply the top and bottom by the square root of 2, and I get 4 square roots of 2 divided by 2. The last thing that I can do here is simplify. Outside of the square root, I have 4 over 2, which is the same as just 2 square roots of 2, and that's the value of x. So I'm going to take this value of x and put it over here. The leg equals x is 2 square roots of 2. And that was my missing side. Okay, in this case, both of the legs are the same measure. So both of the legs equal 2 square roots of 2. Let's take a look at a 30, 60, 90. Okay, I tried to use a highlighter to show you the small side is opposite the 30-degree angle, the smallest angle. Now you can kind of see that it's 30. My highlighter blurred things a little. The large side is opposite the 60-degree angle. And then our hypotenuse is opposite this 90-degree angle. And these are the ratios. So again, I have 1x, square root of 3x, and 2x. My goal is going to be to find what is the value of x. So let's go take a look at this first example of a 30, 60, 90. So in this situation, they gave me that this is 60. This is a box, which means that it's 90. So this angle down here must be the 30. And the side length opposite this 30 is 8. Okay, so my small side is 8. So I'm going to plug in 8 for the word small. And that equals x. So here's what I do now. The large side equals x square roots of 3. So I'm going to use this value of x, which is 8, and I'm going to plug it in here. So I have 8 square roots of 3. And finally, I'm also going to plug it in, and we can prove that this hypotenuse they gave us is 16. But here's how I would get it if I didn't know that. So the ratio is the hypotenuse equals 2 times x. So the value of x is 8. Multiply that by 2. And the hypotenuse is 16. In this situation, they gave me the side length of 15, and it is opposite the 60-degree angle. So the large side is 15. So I'm going to put in a 15 for this L. 15 equals x square roots of 3. And now I need to solve for what is x. So divide both sides by the square root of 3 to get the x by itself. And this will give me 15 square roots of 3 over 3. And so I can simplify. 15 divided by 3 is 5 square roots of 3. So now I know the value of x. It's 5 square roots of 3. So to find the small side, I would just say the small side equals x, 5 square roots of 3. To find the hypotenuse equals 2 times x. X is 5 square roots of 3. And so to simplify this, I would do 2 times 5. These are the numbers on the outside of the radical, which is 10, and bring down the square root of 3. So the hypotenuse is 10 square roots of 3. Okay, let's do another example. So in this situation, while this triangle does bother me, this is the small angle, so this is the small side. This is clearly not drawn to scale because visually this is the larger leg. If we can just ignore the fact that this is not drawn to scale, we can still solve this in the same way. So the small side equals x. So let's do this. The small side is 21 square roots of 3. So that is what x equals. 21 square roots of 3 equals x. So I know the value of x. Let's now find the large side. The large side. So 21 square roots of 3. I'm going to plug this into the large side. It is x square roots of 3. So let's plug in the x. 21 square roots of 3 times that square root of 3. And here's what I will have. The square root of 3 times the square root of 3 is just 3. Bring down the 21. And so the large side equals 21 times 3, which is 63. In this image, the large leg is the y. Okay, so that is 63. Now let's find the hypotenuse, and we're going to ignore the fact that they are using the same letter as our ratio. Okay, so for the hypotenuse, I want to find the measure of that. Hypotenuse equals 2 times x. Well, x is 21 square roots of 3. So I'm going to multiply these. I get 2 times 21 is 42. Bring down the square roots of 3. And that is the value of the hypotenuse. So I'm going to go write this over here. 42 square roots of 3. Okay, so if you flip your paper over, this is our next example. And in this example, they gave me the hypotenuse. They gave me the hypotenuse. It's opposite the 90-degree angle. So the hypotenuse is 3 square roots of 6. I substituted that in for the word hypotenuse. Let's bring down what that ratio is. Okay, and now I need to solve this for x so that I can figure out what the leg is. So let's divide both of these by the square root of 2. By the square root of 2. And this is going to take just a little bit of work for me to simplify, okay? So I do want to multiply the top and the bottom by the square root of 2. Okay, and so what I will get is square root of 2 times the square root of 2 is just 2. And then I will get 3 times the square root of 6 times the square root of 2 is the square root of 12. Okay, and I can simplify that further. I can. So I'm just going to do some scratch work right here. The square root of 12 is the same as 3 times 4, and 4 breaks down to 2 times 2. So a pair of 2's can come out. So here's what I end up with. 3 times 2. There's no pair that goes with that 3, so it's going to stay inside the square root, divided by the 2 that was still on the bottom. Now you could multiply these together and say 3 times 2 is 6, and 6 divided by 2 is 3. Or you could just say 2 over 2 is 1, and I'm left with 3. Either way. 3 square roots of 3 is the value of x. And I had to do a little bit of work to figure that out, okay? And so my value of my leg is x. So plug that in for x, and I get the leg is 3 square roots of 3. Let's try a combination problem. So if the given quadrilateral is a rectangle, find the area. Well, first they told me rectangle and I saw area. So I just wanted to remind myself before I even got started, the area of a rectangle is this formula. Area is length times width. And so this is what I will need to do at the very end to get my final answer. But before I can do that, I currently know this hypotenuse, but I don't know the measures for the length or for the width, okay? So I need to figure these out. So they told me that the hypotenuse is 20. So let's go plug this in to my ratio for the hypotenuse. The hypotenuse is 20. And so let's go ahead and solve for x. Divide both sides by 2. And so x equals 10. Okay, now I can find my length and my width. Okay, so the long side equals 10 times the square root of 3. And the small side equals x, which is 10. Okay, so now I know that my small side, if I marked this down, is 10, and this large side is 10 square roots of 3. And I've been using pink to represent the long side. So, okay. So I just need to multiply these two numbers together. So 10 times 10 square roots of 3 is going to give me 100 square roots of 3. And that's the final solution for this problem. Okay, guys, we have 2 more examples to look at. 2 more. So this next problem tells me that the altitude of an equilateral triangle is 9. So we need to think about what we learned prior to Math 2 about altitude. Altitude creates 2 equal triangles. At least when we have an equilateral triangle, it does. The altitude is the value of the height, and it's going to create a 90-degree angle. So let me write in the altitude. I'll use purple for this. So if I draw a line straight down, this creates a 90-degree angle, and it's going to split these into 2 equal measures. So instead of the whole thing being 60, I'm going to have 30 and 30. So I ended up with 2 30, 60, 90 triangles. And the altitude they told me is 9. Okay, so in one of these 30, 60, 90 triangles, the altitude is opposite the 60-degree angle. It's actually opposite it in both of them. So what I know is that the 9 is opposite the large angle, so it is going to be the large leg. So let's go figure this out. So I'm going to plug it in for the large leg. So the large leg's value is 9. So 9 equals x square roots of 3. Let's go ahead and divide by square root of 3. And so I'm going to get, when I multiply top and bottom by that, 9 square roots of 3 over 3, which I can simplify. 9 divided by 3 is just 3. So the value of x is 3. Now I'm going to use this to help me find the small side. The small side equals x, which is 3. The hypotenuse equals 2 times x. Well, x is 3. So the hypotenuse will equal 6. Okay? So the hypotenuse of either one of these triangles is 6 and 6. And these two smaller sides are 3 and 3, which if you add 3 plus 3 will also give you 6. Okay, 3 and 3. And it wanted me to find the length of one side of this equilateral triangle. Well, they're all the same measures because it's an equilateral triangle. So the answer is 6. Okay, last problem, and then we are done with this lesson and these additional practice problems. Okay, what is the length of side X of this trapezoid? Okay, this is a crazy figure. And so what I have done here is I have broken this figure up into 3 separate figures. So let's take a look at how I did that. Okay. If I draw an altitude straight down here, I will create a 90-degree angle. Okay. Where in this now small triangle, I know that the hypotenuse is 24. So let's go ahead and find out what the length of the legs are going to be. So the hypotenuse is 24. And then the ratio is x squared. It's 2 because this is a 45, 45, 90 triangle. Okay. And let's solve for x. So I'm going to divide by the square root of 2, which will give me 24 square roots of 2 over 2. 24 divided by 2 is 12. 12 square roots of 2 is the value of x. So the leg, both legs, are equal to 12 square roots of 2. So I'm going to go ahead and fill that in my figure. So 12 square roots of 2, and also this is a 45, 45, 90. So this is 12 square roots of 2. Okay. Now, technically, this side of this right triangle and this side of this rectangle are the same side. So they're going to have the same measure. Okay. So this is also 12 square roots of 2. And this is a rectangle. So the side opposite is also 12 square roots of 2, which will make this 12 square roots of 2. Well, how did I get this figure here? What I did was I broke this down with another altitude straight down here. And that's how I got this rectangle and this other small triangle. So using now that I have this rectangle, I know that this bottom side is 20. Okay, so now I've got this little triangle sitting out here, but how do I know what these angle measures are? I know this is 90 degrees because this was an altitude, which forms a 90-degree angle. But are these 45, 45 or are they 30, 60? Here's how I need to figure this out. This whole angle was 120. Well, when I created an altitude, I took away 90 degrees by creating this right angle. So let's do 120 minus the 90-degree angle. And what I end up with is 30 degrees. Okay, so this triangle has a 30-degree angle up here, which means that this down here has to be 60 degrees. So here's what I'm missing out of this triangle to answer the question, what is the length of x? I need to know this side down here opposite the 30-degree angle. Okay, so let's then start with what I know. This is opposite the 60-degree angle, which means 12 square roots of 2 is my large side. So let's do my large side is 12 square roots of 2, and that's equal to this ratio. To figure out what x is, I need to divide by the square root of 3. Okay, I can't leave it like this, So if I multiply top and bottom by the square root of 3, I end up with this, and now I can simplify. So there's two things to simplify. 12 divided by 3 is 4. And the square root of 2 times the square root of 3 is going to give me the square root of 6. So that's what x equals. X is my small side. S equals x, which is 4 square roots of 6. So that's my small side right there. 4 square roots of 6. Awesome. Now, if they had happened to ask me to find the perimeter of this figure, I could do that. I would just need to find one more piece of information, the hypotenuse here. And all I would need to do to find that hypotenuse is to plug in the value of x into the hypotenuse ratio. 4 square roots of 6. 2 times 4 is 8. Bring down the square root of 6. Okay, and so the hypotenuse here would be 8 square roots of 6. So you could actually find the perimeter as well. You would have to add 1, 2, 3, 4, 5, 6 outside lengths together. But as it is here, all they wanted to know was the value of x right here. Okay, x was just the length of this bottom side. So to find the total length, what I'm going to have to do is take these three pieces and add them together. And I can very easily use my calculator to do this. Let me just pull it out, and I just type this in, and it will give me a decimal value. Okay, 12 square roots of 2 plus 20 All right, and so here is my calculator where I have just typed in 12 square roots of 2 plus 20 plus 4 square roots of 6. I'm going to hit enter, and I get 46 point, if I round that to the tenths place, it would be 46.8. 46.8. And that is the final answer. Okay, guys, I'm hoping that this lesson helps clear up a lot of the questions that you still had after lesson 3. This way of organizing is a lot simpler for many of us, including me. And I think that you can understand now better why we are solving for x in each of these ratios and how it's used to help you find the other ratios. Okay? All right, guys. Until next time.